Around 2012, Georg Rottensteiner decided to create a game on the Commodore 64 in assembly. He called it Supernatural and he made a tutorial about it. Now, I've always wanted to learn game programming on the Commodore 64, and I've decided to do a video series on the code that Georg has published. So we're going through the code step by step, and I'm trying to learn game programming as I go. Now, I have some experience in programming, but programming a game like this has always been a dream of mine. So this is not meant to be a tutorial, it's just me learning game programming. I hope you enjoy the video. Hello coders, here we are, looking at firing shots at enemies. Let's just first have a look at what it looks like when we play it. So here we are. I'm the white sprite at the top left, and the rest are automated enemies, and I can fire a shot. Now you won't see any bullets, but I'll shoot this guy until he's dead. 1, 2, 3, 4, 5. So after 5 hits, I know he has 5 hit points. After 5 hits, he dies, right? And when I 1, 2, 3, oh no, I'm hit. Press fire to restart. We see that the killed enemy doesn't come back, and this guy 1, 2 more shots and he's dead. So that's I did edit a little bit of the level. I made this extra platform, otherwise I wouldn't be able to get back up, and I increased our jump range so that I can at least jump up onto this platform. So that's it. So there's shooting. I can shoot. As you can see, I turn red briefly, and enemies get removed when I kill them. So, how do we do this? Let's have a look. Let's have a look at the data first. There is a new table that allows me to check whether or not an object is an enemy based on its type. So it's a table indexed by type. So if I found out an object's type, I could look up in this table whether or not we see this as an enemy, which means that I can differentiate between shooting an enemy and a power-up. We don't do that yet because we just have the player. We have an entry that's not used, we have the player, and we have 2 enemies. So these are true and the others are false. I can't shoot myself and I can't shoot nothing. Also, there is a sprite HP, so there's sprite hit points. They're all initialized to 0. And there's a shot pause that makes for a pause, so that we can't shoot twice in a row. I did edit the jump table, as I said, and I also edited the level. I added this extra platform right here. But that's beside the point. Let's see how we do this. This shooting thing. Previously, the player control started with checking whether or not we were jumping. Now we have preceded that with checking whether or not the player is firing. As you can see, we load the shot pause counter, which is initialized to 0. So at the start of the game, we can just immediately start shooting. If it's not equal to 0, then there is a pause going on, and we have to decrease it and then continue our work. Otherwise, if it is 0, then we've clearly weighted out the shot, and we color ourselves white again so that we can, the player knows that he can shoot again, and then we check for a button press. If nothing happened, then there was no fire pushed, and we can do whatever we were going to do in checking the fall and all that. But of course, we want to know what happens when we did press fire. So a shot was fired. Fire shot is what the function is called. And here we go. We load, as soon as we hit the fire button, we set the player shot pause to 10. Now this in my mind is an arbitrary value. It's a decimal 10. It says frame delay, suggesting that 10 laps of the game loop would be equal to an entire frame, but I don't believe that it's that easy, because a game loop can change depending on whether or not we're falling or we are jumping, so it can never be as precise as this. I think, however, that we just introduce a delay, and that the frame delay function that is in the game loop will help us wait before we can fire another shot. This is like an auto fire prevention technique. So anyway, we set that to 10. Now we know that we've shot. We can mark the player as shooting. We just make him red. We're going to add some animation here later, I suppose, but at this point we just color him red. Then we get, anytime we access a table in this way with no index, we know that we're taking the first element being the player's element. So we're getting our own Y position in the character sense. We decrease 1, which means we go up 1. Now, as far as I remember, that is the character position was equal to our head, but it must be our feet, because going up 1 makes our position equal to our head, which would make sense. So we get basically the Y position of our head, and then we get our X position, and then we check whether or not we were facing right or left. And the difference is because Y is our X position, and we now have to check along the path to our left or to our right, depending on our current direction that we're facing, whether or not the shot is blocking. So if there's a wall there, we shoot the wall and then we're done. Or shot done just is jump out of the routine and go back to the rest of the game loop. Or we check if an enemy was hit. Now I can already tell you that if an enemy wasn't hit, we jump back to shot continue. As you can see, this is a jump instruction. So here we are jumping around in our code, which is sometimes difficult for analyzing code and debugging, because you see a piece of code and you have no idea what the register values mean. Was X the sprite number, or was it our Y position, or what? You have no idea. You really have to keep track of that in your head, or at least in the documentation, which is completely absent. So, which is the whole reason for me making this video series, just so that we can learn, how it actually works. So, but what happens is that within this same game loop, we are checking all of the positions to our left until we either hit a wall or an enemy. And that happens within the same game loop. So, it's just like falling. We were able to accelerate our player by making him move more than 1 pixel in a single game loop. And the same is for the shooting. while we are processing whether or not we hit something that's all within the same game loop. So we check if an enemy was hit. If it wasn't, I know that we get back to shot continue, and when shooting left, the Y position that we're checking decreases, I must say the X position decreases. Shooting right, the Y position increases until we go right. So either the shot is blocked by a wall, a character, whatever, or we hit an enemy. Now, did we hit an enemy? We start, these are important things, X is now, from this point on, X is used as an index again. And we start with index 1. At this point in a single player game, it means that we're not checking the first sprite, which is us, which makes sense because we're the ones who are doing the shooting. So we store that in parameter 2. Again, we have to make sure that we're not using parameter 2 in any function that is calling us at this moment. The function that is calling us cannot assume that parameter 2 will be intact when we come out. So, very important to know that. You're going to be looking for hours for a bug in this. Oh, I'm using parameter 2 twice. The value's changed, and we're looking at something completely different now. Parameter 2 is a sprite number. We check whether or not it's active. Of course, when it's not active, we don't need to check whether or not we hit it. It's just saving time. This is where we use the enemy check. We check whether or not it's an enemy. If it's no enemy, we can just check the next enemy. Check next enemy is, let's check next enemy. It loads the parameter 2, which was the index increase. Are we at the end of the table? Yes or no? Check enemy or shot continue. We can, when if we missed the enemy, then we just keep on checking. This shot continue is just making sure that we go on checking within the same game loop. So it's an enemy. We may have hit an object that is not an enemy. Fine, we keep on checking. So what we do here is, we check? First we check, is the X position the same? If the X position is not the same, then we're sure that we can take the next enemy because we haven't hit anything yet. We do that by getting the sprite number. Y was our own X position. We get the enemy's position and we compare the two. So is the enemy X position equal to the player X position? If it's not, then we can just go on, check the next enemy. If it is, we have to still make sure whether the Y positions are the same, because I can shoot at an enemy, there's 2 platforms above me, but if I'm shooting horizontally, then I'm not hitting him. So we do the same thing. We get the object's Y position. We compare it to our own. Yes or no enemy hit. If it's not hit, then we check also one below us. Did we hit his feet, or did we hit above us? I can test this in a minute, see if this works. I should be able to shoot an enemy that is above me. Maybe. Because if my head were equal to its feet, we'd have to check that. Because that would register as a hit as well. So if this is like, if X is the same and one of these Y's is the same, so these are ORs, then an enemy is hit, yes. If enemy is not hit, at this point, then forget it, check the next enemy. An enemy may be hit here or here or here. If the enemy is hit, then we decrease that enemy's health points by 1. So 1 hit is 1 hit point. or health points, whatever. We load it in, we check it. If it's 0, then the enemy was killed, and otherwise the shot's just done. You know, we're ready for the next shot. We have to shoot him again. If the enemy was killed, we just remove the object, and then the shot is done. We have to realize that X has to be the sprite number before we call this. Otherwise, something weird is going to happen. Check next enemy. We had that shot done is just jump out. So it is kind of a complex function with all the jumping around. It makes sense, but it's kind of complex. So let's check again if I can. I want to get this red guy standing here. I'm going to stand here, make sure that our direction is left. He's going to go over our head, and I'm going to shoot. I don't think 1, 2, 3, 4, 5. See, that's not a hit. That is not a hit. So I'm going to have to, just for checking, 1, 2, 3, 4, 5, 6, 7. No, we're not hitting him. So I'm going to try, and of course I'm going to fail. Try and shoot him. 1, 2, 3, 4, 5. Right. So that's it. If he's if my head is equal to our feet, his feet, then we're hitting. If we're completely equal, of course we're hitting, and if his head is equal to my feet, then we're hitting as well. So that's 3 levels that we have to check. Of course, in level design terms, this is kind of a miss, because I can't get, even with my increased jump range, I cannot get up here. Nope. So that's the way it works, and that was the whole episode basically. It's 15 minutes, 16 minutes, and there's nothing else in this one. So yeah, I know it works. I mean, I know this shooting without a bullet works. I've played the game, and it's still fun actually. It's sort of like you don't need to see a bullet, and it saves a lot of trouble. But it's also because, you know, there's so many games that have bullets. I could introduce a bullet by just creating an object looking for a free sprite slot, and then using that. But what would happen if there was no free sprite slot? You know, would that mean in the game that I can't shoot? What, because there are too many enemies on the screen? That's a weird mechanic. Would I have to remove one object? You know, something just magically disappears because I have to shoot? That's weird. So I'd have to multitask. You know, I'd have to switch one object with the bullet or something like that. It's difficult. So I'm not sure for the actual reason why it was done this way, but maybe it's the thing that I'm describing now. I don't know. Anyway, thanks for watching, and I will see you in the next episode. We'll be on number 13 then, and I'm not sure what that will be, but I'll see you then. Bye-bye.